Good afternoon. Thank you for coming today. I know you're all experienced teachers, so I'm not trying to tell you how to do your job better. I just thought I'd share a math problem I recently tried to teach my grade 4 class on placement. At the end I'll show you some footage. I hope it's not too bad, how it actually turned out in real life. Here's the problem. We have tripods and bipods from planet Zeno. They arrived on Earth, and between them they have 23 legs. How many were there each to make 23? There has to be a minimum of 2 of each species. When I planned the activity, I tried to incorporate the curriculum and many mathematical thoughts and concepts like reasoning, understanding, problem solving, and multiplication fluency. My theoretical approach fell somewhat short, as you will see, once I opened the problem up for suggestions. What then came next was me improvising and adapting to what the children suggested. I then began my presentation of the problem by just telling the class the first part without telling them about the pair condition. I didn't elaborate on how to calculate. My original first question was, what could bipods and tripods be? And I was going to present them with other number words like tricycles and bicycles and things like that. But someone in the front row started off by saying, of course they are aliens. So that was ended. With the discussion on the number words shut down, I moved into phase 2. The plan was to leave out the part with the pairs of each and just talk about the numbers and how we could make 23. This part went according to plans. The student participated well, and we were able to establish that our most critical information came from the 2s and 3s timetables. So I asked a few students to give me numbers from those timetables, and I wrote them on the board. Next, we drew up a table with the 2s in the left column and the 3s in the right. I tried to keep them entertained by drawing aliens up instead of just writing the numbers. One student had done a similar calculation before, and it took a lot of persuasion to keep him from just blurting out the answer. After I wrote most of the numbers on both timetables, I asked him to eliminate the ones that we couldn't use. One student suggested using just 1 tripod and 10 bipods. I acknowledged that that was a valid suggestion, and he used great calculation skills, but at this stage we had to introduce our condition. We can't have just 1 of each. So we need to send them in pairs to Earth. So we're now trying to create groups or pairs of 2s and 3s, and that way make 23. No other way. Once we eliminated numbers one by one we couldn't use. There couldn't be more than 9 bipods. 10 would make 20, but once again that left us just with 1 tripod. 2 tripods would have 6 legs, so we needed to take 6 away from 23 and then work out how many bipods we could use. Some numbers, when they were taken away from 23, didn't leave us with the right amount of numbers from the 3 times tables. For example, 3 bipods made 6 legs, but then 6 taken away from 23 came to 17, and 17 is not part of the 3 timetable, not a multiple of 3. Now I was discussing number 23. What kind of number is 23? I was expecting someone to get to it's an odd number, but instead a smart kid called out it's a prime number. Really? Eventually we got to the word odd. What are odd numbers and what are even numbers? Yes, they can be divided or shared into 2 even halves. Can we make even halves out of 23? No, we can't. There's always 1 more on either side. Back to the bipods. They are always even, right? Because they're made out of 2s. So we're testing a couple of numbers. 2's even, 6, 14. Yep, they're all even. So what do we need to add now to get an odd number result? Yes, true, we need to add an odd number. We returned back to our table and had another look. There were a lot of even numbers on the 3 timetables, so we had to cross each of them out to get back to our calculation. While I was crossing out the numbers, someone suggested we could try 3 tripods, meaning 9 legs. Then I asked someone else, how many bipods would we need and how can we work this out? We could take away the 9 from the 23. I got someone to do that on the board, and we ended up with 14. Back to the bipods, another person. How can we make 14 legs? Right, by using 7 bipods. And we have our first answer. In the same way we got to the second answer. Once the unsuitable options were crossed out of the timetable, it became easier for the students who had previously not quite caught on, and they were able to look. There was 15 left, 15 legs, 5 tripods, and then we got to 8 legs, 4 bipods. Once again, I suggested they deduct the first amount from the 23, and then they got to the second one much, much easier. Compliments to the boy in the front who had worked it out ages ago, and he managed not to call out. I felt this was a great task to incorporate addition, subtraction, multiplication, mathematical terminology. There was even division, odd and even numbers, It involved a bit of critical thinking and problem solving skills. I try to use the board as much as possible because I think there's nothing worse than someone just talking and without visual cues. Whenever possible, I try to involve the students and let them draw or write alongside me. The concept I aimed at covering were all from the grade 4 number and algebra substrand of the Australian curriculum. There were 5 from number and place value and 1 from the patterns and algebra, because we made patterns out of 2s and 3s. Thank you for your time. As I said, I'm aware you all have your own tried and tested methods, but perhaps my approach was a little bit different and gave you a new perspective. Here's some footage from my math class. Okay, so that would be 6. And then how many? So if we take 6 away from 23, what do we have to make?
So 6 blackbirds and 4 trash bags, I think.
But if I take 6 away from 23, I don't know who's good at doing this in their heads. You? What have we got left?
I've put them away.
Okay, 1 second.
17.
We have 17. Can we make 17 out of 3 times table? 17 in our 3 selection.
No.
Okay.
Add two tripods.
Okay, well with that particular answer we couldn't do it. So we can't start off with the 6 bipods. But that was a good try. So you just said we can change it. What can we do? So
Add 2 more tripods.
2 more tripods. That would mean we would have 5 again, but that's the answer we've already got. So we need to find a different combination. It was good thinking there. Okay.
3 tripods and 7 bipods.
Alright, let's see if that works. We'll go back over here and hope the pen doesn't let me down. So 3 tripods is how many legs? Who wants to do the calculation? 3 times 8.
Tripods is 9. 9 legs.
9 legs, well done.
3 times 9. And 7 bipods.
And 7 bipods is how many legs?
Is 14 legs.
14. And who wants to add them together?
Yes, you can.
Can we add that together and make 23? Otherwise we have to start over. Good? You agreeing? Is anyone else agreeing? How we getting to 23?
I agree.